Hello and Happy New Year to you all. Hopefully you've managed to have a go at the first of the remote learning work that was set yesterday, getting used to drawing visual representation of vectors. So before we get underway with the new learning today, why don't you just have a go at recapping the learning that was covered in the last lesson. So you'll see I've given you here two vectors. We've got vector A and vector B. I would just like you to quickly sketch three vector diagrams to represent the vectors 2a, a plus 3b, and 2b minus a. So if you maybe pause the video now, have a go at doing that, and then I'll reveal the answers just in a few seconds. Okay, so here are the answers you should have got for the starters. You'll see for 2a, all we need to do is represent the vector a, but double it up. So we have two lots of a to give us the new vector 2a. In the next one, a plus 3b, we had vector a, and then we simply add nose to tail to it, 3 vector b's. And then our resultant vector, our new vector a plus 3b, is the line from our start point to our end point. And then we need an arrowhead on that to show what point did we start at, what point did we finish at. And then a very similar thing for the last one, 2b minus a. Just simply draw 2b vectors, and then to take away an a vector, we need vector a going in the opposite direction. And again, our new vector just joins our start point to our end point with an arrowhead to show what way it's going. Before we move on to the new learning today, you will see I've put together here just a short note for you. I think it would be worth you having this copied into your notes jotters. So why don't you pause this video and just get this note copied up that's on the screen just now. Basically just recaps what a vector is, what we use them for, and the notation that's involved working with vectors. So in today's lesson, we're going to start looking at using vectors to describe the journey between two specific points. So I've got here just a vector between points A and B. So we are used to already either we can call that the directed line segment from A to B, which we show with a wee arrow to indicate we move from point A to point B, or more commonly, we just use a letter to represent this vector. So this could be the directed line segment A to B or vector U. But what we're going to do today is we're actually going to introduce specific coordinate points for A and B. So if I said that A was the point 3, 5 and B was the point 7, 8, then what we're interested in is what is that journey between from A to B? How do I get from the point 3, 5 to the point 7, 8? So you might recognise this from the distance between 2 points or your Pythagoras in S3. How would I describe my journey getting from 3 to 7 in the x-axis? Well, I've obviously moved along my x-axis 4 to get from 3 to 7. And likewise in the y direction, how do I get from 5 to 8? Well, I've obviously moved up my y-axis 3. So this journey, this vector from A to B has the components. It has a move in the x direction of 4 and a move in the y direction of 3. So we can write that vector in what we call column form. And this is the move in my x direction, which was 4, and this is the move in my y direction. Okay, so vector U, it has the components 4, 3. That means move 4 in the positive direction on the x-axis and move 3 in the positive direction on the y-axis. So we could look at another vector, let's call it vector V, and if we said it had the components -2, -3, well, what that tells me is from the start point of vector V, this -2 tells me I go back in my x direction. So I'm actually going to go to the left for 2, and then the -3 tells me in the y direction I need to move down. So I would move down 3. So what would my vector V look like? Starts at this point, moves left 2, down 3, So that would be vector v, minus 2, minus 3. Basically means to the left 2 and down 3. So we've got two vectors now in component form, written as column vectors, 4, 3, negative 2, 3. Let's just have a look at a couple of quick examples of how we might add these, subtract them, or multiply them by a scalar. So you were doing this yesterday where you were just drawing your vectors, but today we can actually start putting values on it. So if I said example A, we wanted to do u plus v, then we know we could draw these two vectors added together, but today we're going to work with them in column form. So all I'm going to do is write my components of vector u and add to it the components of vector v. And now all I have to do is I just add my x components and add my y components. So my x components are 4 plus negative 2, which would give me 2, and my y components are 3 plus negative 3, which is 0. And that is what's called the resultant vector u plus v. It means to get from the start point, when I add u to v, I would move along 2 and up 0. So we can do a similar thing then. Let's have a look at multiplying them by a scalar, maybe introducing a negative as well. So if I did 2u minus v, that basically just means I want 2 of vector u, which is 4, 3, and I'm going to take away from it vector v, which again is just negative 2, negative 3. So I can work out the components of 2u first if I want. That would be 8 and 6, because I'm just multiplying 2 times 4 and 2 times 3. And then I want to take away from that negative 2, negative 3. And all we have to do here is we just need to be careful with our negatives. So x components are 8, take away negative 2, which would actually give me 10, because taking away a negative is the same as adding. And then I've got 6, take away negative 3 is 9. And that is the resultant vector if I had 2u minus v. And I mean, I could sort of quickly sketch that, I suppose. There's vector u. So we said we wanted 2 of these vector u's. And then we were going to take away vector v. Now vector v was like this, so vector negative v will actually go the opposite direction, so that would be negative v. And what this 10, 9 tells me is from this start point here to this end point here, I would have to go along 10 and up 9. So I have basically drawn in that vector there, that red vector is 2u minus v. So hopefully we were able to follow those worked examples I've just done. If you feel ready to move into the textbook, then you'll see here the page I would like you to do today with some suggested questions. Today I'm suggesting questions 1, 2, 4 and 5. There is no reason why you can't do 3 and question 6 as well if you want. You should be spending about an hour on these lessons, so by the time you've watched the video and done some textbook work, then you should probably find that that's certainly filled an hour for you. If you feel you're still unsure of anything, I would suggest you maybe rewind the video, have a look back at it, watch the examples again, then have a go in the textbook. If at that point you're still not sure what's going on, then as always you can get in touch with me through Teams or through my Glow email, and then hopefully I'll be able to provide a bit of extra assistance. I hope everything's going well for you at home. It take a wee while to get settled back into this remote learning, but if there's anything you feel that we can be doing to support you, then as always just get in touch and let us know. Okay, see you later.